Alright, in this example we're going to solve simultaneous linear equations using matrices. We're going to use the augmented matrix and elementary row operations method, which is known as like Gaussian elimination. So say we've got three equations which are all true, so they're like simultaneous. Say you've got 3x plus 2y plus 1 lot of z is equal to 1, and also we know that say 2 lots of x plus 1 lot of y minus 1 lot of z is equal to minus 2, and also say minus 1 lot of x plus 2 lots of y plus 3 lots of z is equal to 11. Alright, so these three equations are all true and they're all correct, but we need to try and solve them to find out a value, to find out what x is, what y is, and what z is. Okay, so we've got three equations, so we can find three unknowns. And where matrices come into it, so we've got our matrix of coefficients. We've got 3x, 2y, and 1z is equal to 1. We've got 2x plus 1y minus z is minus 1z is equal to minus 2. And then we've got minus 1x plus 2y plus 3z is equal to 11. Now this is where the matrix has been augmented, because where it all comes from is you've got your coefficients. We've got 9 of them, and what we would do using matrix multiplication, we would multiply by x, y and z, and that would equal the answers as in 1 minus 2, 11. And we know these numbers, but what we don't know is what x, y and z are, so we're going to use matrices to work them out. Some of the rules of Gaussian elimination is you can swap any rows, but you have to use the whole row. So this first row you could put at the bottom. You can multiply any whole row by a number or divide by a number, as long as you do the same to each element. And you can also multiply a row by a number and add it to another row, because then we're not really changing any equations. Like if we wrote all of these rows out and divided them all by 2, then the answers would divide by 2 and they would still be true equations. They're just kind of equivalent equations. But anyway, what we want in this case, when we come up with our matrix including like what I call the answers, got the matrix of coefficients, we want a 1 in the top left, because then it's easier to multiply a row when it's got a 1 in the top left. It makes the sort of multiplication easier. And then in the second row we want a 0 there, and then 2 numbers. And in the third row we want 2 zeros, and then only 1 coefficient left there. So going from top row to the bottom, we want 3 numbers or 3 coefficients, then second row 2 numbers, then third row just 1 number, because then it's easy to say n times z equals 11 or whatever, so then it's easy to find out what the z coefficient is. So that's where this comes from. We want the bottom left to be all zeros. So we've got our matrix of coefficients, and we've also like appended or made this matrix augmented by putting the answers in with it. So the first thing I'm going to do, because this row 3 is already starting with a 1, even though it's minus 1, I'm going to move the row 3 and put it at the top, then slide the other 2 rows down. There's nothing wrong with that. As long as I do the whole row, including this part, then I'm not changing anything. And because this starts with a minus 1, I'm going to multiply the whole row by minus 1 to make this first number positive, and then I'm going to write the row at the top. So that'll become 1 minus 2 minus 3 minus 11, and I'm going to shift the other rows down. So row 1 is now row 2. It's going to become 3, 2, 1, 1, and then row 2 is now row 3. So it's going to be 2, 1, minus 1, minus 2. So the first thing that we want to do is get the first row with a 1 at the start. So we've sort of ticked that off. The next thing we want to do is to get the second row starting with a 0 through multiplying and like accumulating, if you like, multiplying and adding or subtracting a row to get this to be 0. So if we want to get this 3 to be 0, we need to somehow add minus 3 to it. So to get minus 3 from another row, we could multiply this row by minus 3, because then we've got minus 3 times 1. So what we're going to do is multiply row 1 by minus 3, add it to row 2, and then put that answer as the new row 2. So it'll be minus 3 lots of 1, minus 2, minus 3, minus 11. So that's minus 3 lots of row 1. Then we're going to add it to what row 2 already is, and then we're going to put the answer as the new row 2. So scalar multiplying this left hand side here, with 3 lots of row 1, it's going to be minus 3 times 1 is minus 3, minus 3 times minus 2 is 6, then 9, then minus 3 minus 11s are 33, plus 3, 2, 1 and 1 gives us row, element by element. It's going to give us minus 3 plus 3, 0, 6 plus 2 is 8, 9 plus 1 is 10, and 33 plus the last one is 34, and that's the new row 2. So we can rewrite the matrix now. Row 1 is no longer that, we've changed it to this. So row 1 is 1, minus 2, minus 3, minus 11, and the new row 2 is 0, 8, 10, 34. And row 3, we haven't done anything to row 3 yet, so it's still the same. So it's 2, 1, minus 1, minus 2. Remember, what we need is 2 zeros at the start of row 3. Now, to get the first one, we need to multiply somehow and then add, so that this 2 becomes 0. So we need to add minus 2 to it. And to get minus 2 from another row, we can't use this row because that's 0. So you can't multiply 0 by anything to get minus 2. But you can multiply 1 by minus 2 to get minus 2, add it to this 2 to get 0. So what we're going to do now, minus 2 lots of row 1, add it to the current row 3, and put the answer as the new row 3. So that'll give us minus 2 lots of row 1, which is 1, minus 2, minus 3, minus 11. Add it to the current row 3, 2, 1, minus 1, minus 2, and shove the answer as the new row 3. So scalar multiplying here, minus 2 lots of 1 gives us minus 2, minus 2 minus 2s is 4, minus 2 minus 3s is 6, and minus 2 minus 11s is plus 22. Added to 2, 1, minus 1, minus 2, element by element of course, is going to give us minus 2 plus 2, gives us the 0 that we needed. 4 plus 1 is 5, 6 plus minus 1 is 6 minus 1 is also 5, and 22 plus minus 2 is 22, take away 2, gives us 20, and we're going to put that as row 3. So we'll rewrite the matrix again. We've got 1, minus 2, minus 3, minus 11, 0, 8, 10, 34, and now not this row 3 anymore, the new row 3 is now 0, 5, 5, 20, and we're nearly there. What we need to do next is turn this 5 into a 0 somehow through the same sort of process. So what can we multiply and kind of add or subtract to like, how do we multiply a row to get rid of this 5 to make it 0? Well, we can't really multiply row 1, because if we multiply row 1 by anything apart from 0, we're going to end up with a number here that isn't 0. So we need to figure out what we can multiply to get this 5 equal to 0. So we need to add a minus 5, if you like, multiplying another row. So how can we get from the number 8 to minus 5? Well, if you think about it, 8 times 5/8, the 2 8's cancel and you're left with 5. So it stands to reason, if we multiply 8 by minus 5/8, that'll give us, when the 8's cancel, that'll give us minus 5. So this tells me, take row 2 and multiply it by minus 5/8 to get rid of this 5 here, because when we add minus 5 to that 5, it will come to 0, which is what we want. So we're going to do minus 5/8 times row 2, then we're going to add that to the current row 3 and put the answer as the new row 3. So let's multiply first. Minus 5/8 of row 2 is 0, 8, 10, 34. Then add it to row 3, so we'll add that answer to 0, 5, 5, 20, and we'll put the answer in row 3. I suppose I should have used the curly bracket, but who cares. So doing this scalar multiplication, minus 5/8 times 0 gives us 0, minus 5/8 times 8 gives us minus 5, which is why we did this in the first place. Minus 5/8 times 10 is minus 58, and minus 5/8 times 34, well, 5 34s are 150 and 20, so it's minus 170. I always write that backwards, I don't know why. Minus 170 over 8. And now we're adding 0, 5, 5, 20 to that. I'm going to shove it in R3. But how do you add minus 58 to 5? How do you add minus 178 to 20? You need to express the similar positioned element as 8, basically. So 5 is 5 lots of 8/8, because 8/8 is 1. So 5 lots of 8/8 is 48, and 20 is 20 lots of 8 over 8, which is 168, which makes it a lot easier to add. So when we do add these two rows, element by element, 0 plus 0 is 0, minus 5 plus 5 is 0, minus 58 added to 48 is minus 10/8, and minus 178 added to 168 is also minus 10/8. So that is the new row 3, because we said we'd put the answer into row 3. So we can rewrite the matrix: 1, minus 2, minus 3, minus 11, 0, 8, 10, 34, and not this row 3 anymore. This is going to be the new row 3, as we said we're going to put the answer in row 3. 0, 0, so we've got the two zeros we needed. Minus 10 over 8, minus 10 over 8. We're really close to solving for x, y and z now. So what we'll do now, whereas we had augmented and like sort of stuck together the coefficients of x, y and z with the answers, like the constants, we're going to split them up again now. So this is why we wanted two zeros here, because we've got 0 times x plus 0 times y plus minus 10/8 of z equals minus 10/8. So rather than writing 0 times x and 0 times y, let's just start at the first one that isn't 0. So minus 10 eighths times z, because you know how to multiply matrices, equals minus 10 eighths. So the minus 10 eighths cancel and z equals 1. But if you want to make sure you're doing it right, a product here, two factors, then z is equal to minus 10 eighths divided by minus 10 eighths, which cancels to be 1. So we know we've solved that z is 1. So I'm going to write it up there, because we need to use that to solve x and y. So the next one we'll do is the second row, 0 lots of x plus 8 lots of y plus 10 lots of z, which we already know, equals 34. So rather than writing 0x, there's no point. I'll just do 8y plus 10z equals 34. But we know that z is equal to 1. So 8y plus 10 lots of 1, which is 10, equals 34. Therefore, 8y is 34 take away 10, which is equal to 24. So 8y is equal to 24. Therefore, y is equal to 24 eighths, which is equal to 3. So we can write that down here. Y is equal to 3. So we've solved z and we've solved y, and now it's going to be easy to solve x. So we've got 1x minus 2y minus 3z equals minus 11. So we've got x minus 2y minus 3z equals minus 11. Multiply both sides by minus 1 to clean it up a bit. You've got minus x plus 2y plus 3z equals positive 11. But we know that y is 3 and we know that z is equal to 1. So this gives us minus x plus 2y, which is 2 lots of 3, minus x plus 6 plus 3 lots of z, which is 3 lots of 1. So that's 3 equals 11. So minus x plus 6 plus 3 equals 11. If we get minus x on its own, minus x equals 11, take away 6, take away 3. So minus x is equal to 11, take away 9, which is equal to 2. So if minus 1 lots of x is equal to 2, x is equal to 2 over minus 1, or minus 2. So now we've solved x equals minus 2. And that is how you do it. And if you plug these numbers back into the original equations, you'll find that they do work. So that is how to solve linear equations with three unknowns using matrices and the Gaussian elimination method. If you've got any questions, just feel free to comment, and thanks for watching.